Hi everyone. Today we're going to study shifting property for inverse Laplace transforms. In this video, we're going to evaluate Laplace inverse of the function with respect to s plus a, or Laplace inverse of the function with respect to s minus a. If Laplace inverse of the function f of s is equal to the function f of t, then we have this Laplace inverse of the function with respect to s plus a. The answer is e raised to the negative of at times Laplace inverse of the function f of s. Also, Laplace inverse of the function with respect to s minus a. This is equal to e raised to at times Laplace inverse of the function f of s. Example 1. Find Laplace inverse of s minus 1 all over the square of s minus 1 plus 9. This problem here falls on the category Laplace inverse of the function with respect to s minus a. The s minus a is that value s minus 1. It means the a is equal to 1. Then later, the formula is equal to e raised to at times Laplace inverse of the function f of s. For our step 1, let us identify that function f of s. In here, we will do the shifting. Looking at the function here, the f of s is equal to s all over s squared plus 9. Then, step 2. Let us now evaluate our problem in here. It means the formula is e raised to 1 times t times Laplace inverse of this s all over s squared plus 3 squared. In our formula, we have this Laplace inverse of s all over s squared plus a squared. And this is equal to the cosine at. So the final answer now is e raised to t times the cosine of 3t. Example 2. Find Laplace inverse of 4 all over s squared minus 2s plus 5. Let us copy our problem down here. Let us show that this constant 4, we can pull it outside to be like this. So we have 4 times Laplace inverse of 1 all over this trinomial. And then we will do the process of completing the square. Look at the first two terms here. This is s squared minus 2s. These are the two terms of perfect square trinomial. We need the third term, and that term is the value 1. We can take the value 1 from the constant 5. We're going to split 5 into two values, which is 1 and then plus 4. Then we put the trinomial in one group, the s squared minus 2s plus 1, where we can simplify this and factor out into square of binomial. So we have this s minus 1 and the quantity is squared. Plus, this number 4, let us show that this is 2 squared. And for this Laplace inverse, it falls on this category, Laplace inverse of the function f with respect to s minus a. The s minus a here corresponds to this s minus 1. Therefore, the value of a is equal to 1. Later, this is equal to e raised to at times Laplace inverse of the function f of s. Let's go to step 1. Let's identify the f of s. Let us now do the shifting. Looking at our fraction here, the f of s now is equal to 1 over s squared plus 2 squared. Then, step 2. Let us now evaluate our original problem. A while ago, we simplified this into the value 4 times Laplace inverse of 1 all over the square of the quantity s minus 1, then plus 4. Using the formula, we have now this 4 times e raised to 1 times t, multiplied by Laplace inverse of the f of s, which is 1 all over s squared plus 2 squared. We have Laplace inverse formula that says 1 all over s squared plus a squared is equal to sine 80 all over a. Let us use this formula to simplify this Laplace inverse. So we have now this 4 times e raised to t times the sine 2t all over 2. We can simplify further by cancelling this constant 4 with the denominator 2. So final answer is 2 times e raised to t times sine 2t. Example 3. Find Laplace inverse of 1 all over the quantity s plus 3 is raised to 4. Our problem here is on the category Laplace inverse of f with respect to s plus a. The s plus a corresponds to this s plus 3, which means the value of a is equal to 3. Later, this will be equal to e raised to the negative of 80 multiplied now by Laplace inverse of the function s. Then step 1. Let us identify the f of s, which means we will do the shifting property. Looking at our problem here, the f of s is equal to 1 over s raised to 4. Then step 2, let us now evaluate our original problem. And this is equal to e raised to the negative of 3 times t, multiplied by Laplace inverse of 1 over s raised to 4. Remember that we have a formula for Laplace inverse that says 1 over s raised to n plus 1 is equal to t raised to n all over n factorial. Let us use this formula to simplify the Laplace inverse here. So we have now this e raised to negative 3t times t cubed all over 3 factorial. Let us simplify this 3 factorial, and that is 3 times 2 times 1. Then we combine this e raised to negative 3t with the numerator. So this is now the final answer. I hope you learned something from this video. See you again next time.